Hello, my math friends. This is Mrs. Schlecht, and in this video, we're going to simplify expressions. All right, my friends, so you know before we get going, there's a few materials that you need in order to be successful for this activity. First, you're going to need your Envision book. We are still in Volume 1, still with our little robot friend. Second, you're going to need your math notebook so you can take those beautiful math notes. Third, you're going to need a pencil. And fourth, last but certainly never least, that positive math attitude. All right, my friends, so this video goes super duper well with lesson 4-3, which goes over simplifying expressions. The key concepts page for this lesson can be found on page 212. Okay, so if you are like Mrs. Schlecht, you see something like this and your math anxiety starts like just firing, right? It starts looking like super complicated, but this is the whole point of this lesson, my friends, right? To take something that looks big and complicated and long, and we're not going to change the value. No, not changing the value, but we're going to change the look of it. We're going to like give it a shortcut, right? So that it still has the same value, but it's not this complicated, right? That we can actually like look at it and like know what to actually do, okay? So this example comes from that key concepts page, okay? Again, page 212. And let's just read this whole thing, all right? So we have 3/10 y minus 3.5x minus 3/8 plus 53 tenths times x plus 5 and 25/100 minus 2 and 75/100 y minus 12. Woo! Look at that! That's a lot of stuff. But we can simplify it, my friends. We can make this thing a lot less scary and actually work for us. So what we're first going to look for, my friends, is something that we call like terms. All right, so what like terms mean, my friends, is either you are multiplying it by the same variable. So side note, make sure you notice we got y's, we got x's as our variables, all right? They're not the same. So therefore, if you have a coefficient with a y and a coefficient with an x, they're not equal to each other because that variable is different, right? Different letter, different variable, different value. Just make sure you remember that. But a like term are those terms that have stuff in common, right? They're like alike each other, right? So over here we have 3/10 times y, and that is a like term with 2 and 75/100 y. Why are they like terms? Because they have, yes, a coefficient, but that same variable. So now what I'm going to do is I want to pull these two like terms together, and let's see if we can simplify them. So when I pulled out those like terms, I know that 3/10 y, we can also rewrite this as a decimal as 0 and 3/10 y. The reason I turned this into a decimal, my fine friends, is because this was in a decimal, right? So I kind of wanted that same unit, all right? So now that we're looking at this, my friends, we have a positive 3/10 y, and then we're going to subtract 2 and 75/100 y as well. So what I want to know, my friends, is, well, how many y's do I actually have? So when we do our actual math, right, when we start simplifying, we know that 3/10 y minus 2 and 75/100 y will give us 2 and 45/100 y. But remember, it's going to be negative. All right, so what I did over here, my friends, I just made a note for ourselves that we remember that when we combined our different coefficients with y, our final like simplified y version was negative 2 and 45/100 y, right? So this is just to kind of like keep in our heads, we're going to use that later, okay? But now I want to look at those coefficients with an x, all right? So we have negative 3.5 times x. And then over here, we have 53/100 x as well. So again, those are like terms because they both have that same value, all right? So now we're gonna pull those out, and now let's simplify. All right, my friends, so again, we're now trying to simplify to see how many x's do I actually have, right? So I have negative 3.5x plus 53 hundredths x. So how many total x's do I have? All right, so when you do that math, you find out that our simplified version for all of those x's would actually be negative 2 and 97 hundredths x. So now, my friends, I have taken care of all those coefficients with the variables, right? We were able to simplify our y, we were able to simplify our x. But if we look at our original problem, you'll see that there's some numbers that don't have a variable, right? They are just our numbers. And those are like terms, all right? So we have 3/8, we have 5 and 25 hundredths, and we have 12. Again, those are all like terms. Now, I know we got a fraction, we got a decimal, we got a whole number, but the reason they are like terms, my friends, is because I'm not multiplying them by a variable, right? They're constant. That value is going to stay the same, right? And we know, like from back in the olden days, like, you know, first, second grade, that we can add and subtract just regular old numbers, right? So those are like terms. Now let's pull them all out, and now let's simplify. All right, so when we pull out all these like terms, we have negative 3/8 plus 5 and 25 hundredths minus 12. Now what I'm going to do, my friends, to help my Mrs. Schlecht brain figure it out is, notice I have a fraction, then I have a decimal, then I have a whole number. I'm going to make this fraction into a decimal so that they all kind of have the same format. But remember, when I convert this into a decimal, I am not changing the value at all, my friends. I'm just changing the look. So once I've made that conversion, my friends, I actually have negative 375 thousandths plus 5 and 25 hundredths minus 12. Again, I did not change the value, I just changed the look. So now let's simplify it. All right, so once we performed our operations, we've added, we've subtracted, our final answer is negative 7 and 125 thousandths. So now, my friends, what we have done is we've taken this big old long expression and we have pulled out those like terms and then we simplified these like terms. But, this is not an expression. This is not our final answer. So now what we need to do, my friends, is we need to write this information as an expression so that we can show that this expression will be equivalent to this expression. So our final expression could look something like this, where we have that negative 2 and 45 hundredths y minus 2 and 97 hundredths x minus 7 and 125 thousandths. Now remember, my friends, this big long expression, this expression, they're equal. They're the same, right? They have the same value. Yes, they have a different look, but remember, the value has stayed the same. All right, my friends, so now that we've kind of like figured it out a little bit, let's get to some practice problems. Woohoo! So the first one that we're going to look at is page 212, and it's number 5, all right? So what it's asking us to do is to simplify this big old expression. So we have negative 2 plus 6 and 45 hundredths z minus 6 plus a negative 3 and 25 hundredths z. Now notice, this is in parentheses, yes, but it has nothing to do with multiplication. The reason it's in parentheses is so that you understand that you're adding a negative amount, all right? It's just kind of helping our brain stay organized. So like we did in that last example, we note the first part, we need to pull out those like terms. And remember, a number just by itself, no variable friend, and a number by itself, no variable friend, those are like terms. So let's pull those ones out first. All right, so when we pull out those terms, we have negative 2 minus 6. And we know that the answer then would be negative 8. So how can you simplify this expression? It's negative 8. All right, so now that we've dealt with just like the regular old numbers, now let's look at those variables and their coefficients. So z, right? That is our variable. And those coefficients that are being multiplied by z, those are like terms. So I pulled those out, and we have 6 and 45 hundredths z plus a negative 3 and 25 hundredths z, right? So those are like terms. Now let's simplify it. All right, now when we simplify it, when we perform that operation, we get a final answer of 3 and 2/10 z. So over here, I have just written down what our simplified terms were, right? We had -8 when we added all of our numbers that we had. We had 3 and 2/10 z when we added those coefficients with their variables, right? But now how would I write our simplified terms in an expression? So my friends, great job. There's two different ways that you could write this expression. You could either say 3 and 2/10 z minus 8, or you could say -8 plus 3 and 2/10 z. Again, equal, equal, they're all equivalent, right? So we did not change the value at all, my friends, right? We just changed the look of it. We gave it kind of a shortcut so that we can actually solve this without having all those other steps. All right, my friends, so there's one more problem that I'd like to look at together. This is on page 213, and it's number 12. The neat thing about this problem is that it gives us 4 different possible equivalent expressions that have been simplified, right? So I don't know, one of these could maybe possibly be the right answer. So what we're supposed to do is we're supposed to take this big, long expression. We want to combine those like terms to simplify it. And then we want to see, is that equivalent to 5 plus x, 1/3 x minus 5, 1/3 x minus 1, or 1/3 x minus 5. So now, my friends, what we're going to do is let's start pulling out those like terms. So first, I want to start with that variable and those coefficients, because why not, right? So when I pull out those like terms, my friends, I have 2/3 x minus 1/3 x. And I know that fractions might be a little scary, but it shouldn't be, right? Look at this, same denominator, right? So they're common denominators. You don't have to worry about any type of conversion. And you're just doing 2 minus 1. And 2 minus 1 is 1. So when I have 2/3 x minus 1/3 x, the simplified version of that, my friends, is 1/3 x. And notice it's a positive 1/3 x because I started with a larger value and then I subtracted a slightly smaller amount, right? So my answer is still positive. So now what I want to do is I just want to look at any of my answer choices. And what I'm looking for is anything that does not have a positive 1/3 x, because remember, that's what my simplified version actually is. So which one does not have that? Oh, choice A, there is no positive 1/3 x, so that's not even an option, right? Now part B, I have negative 1/3 x. And again, we know it's supposed to be positive. So that means B, yeah, get out of here, B, you're not even close to it, right? All right, so now we have C and D, and both of these options have that positive 1/3 x. That's telling me I'm in the right spot, right? I'm doing well, and it's either going to be C or D. But how do I determine which one is the right answer? Well, my friends, I still have some other like terms that I need to combine. So now let's combine -3 plus a -2. All right, so when I pulled out those like terms, it gives me -3 plus a -2, which we know is equal to -5. Very nice. So again, my friends, here are my simplified terms, right? Let's put that in an actual expression, Mrs. Schlecht. So our final simplified version of this big ol' expression is actually 1/3 x minus 5. And if we scooch on over to our answer choices, we will see that choice C has us subtracting 1. What? Actually subtracting 5. So I'm sorry, choice C, but see you later because you're incorrect. So that means that we only have one answer choice left, and that's option D. And that says 1/3 x minus 5, which, look at that, same, right? So again, my friends, we went from this big expression, we simplified those like terms, and it got us a shortened version of it, right? But never did we change the value of anything, right? This and this, still equivalent, different look. All right, my friends, so that was just a quick run through of lesson 4-3, which again, went over simplifying some expressions. If you have any other questions, please let me know.